Dear students, as you know that in order to estimate the unknown value of the population median, we can use the confidence interval estimation approach. If our sample size is large, we are going to talk about the large sample confidence interval of scientists for the unknown value of the population median. In this module, we'll be taking another example, a practical example that I'll be demonstrating in order to find out the unknown value of the population median. So this is a particular problem that I've taken. For the data which is being given, students, we are required to construct a 95% confidence interval, whereas the population median is unknown to us. As you can see that this data is in raw form. Now, in order to calculate the confidence interval, so that we can easily locate the lower limit of the confidence interval as well as the upper limit of the confidence interval, the first and foremost thing we would have to do is to arrange the data from the smallest to the largest observation. So students, this is the data array. Here you can see that the data is being arranged from smallest to the largest observation. Now, I'm going to follow the procedure for identifying the unknown values of the population median using the confidence interval approach. Now, as you can see that the confidence interval was 95%, that means 1 minus alpha was equal to 0.95, so alpha will be 0.05 and alpha by 2 will be 0.025. The total number of values we have had are 20. Now we are going to use the large sample approximation, students. Why? Because our sample size is quite large to follow it through large sample confidence interval approximation approach. Now again, we'll be making use of the large sample approximation. The formula here is k dash plus 1, which may be approximated using the formulae n by 2 minus z alpha by 2 n by 4 under root. Now students, by plugging the values into this formula, where n is equal to 20, z alpha by 2 is 1.96, as you have already learned that how to locate this value for alpha by 2 from the normal table. So that value is determined as 1.96 and this is being multiplied by 20 by 4 under root. So students, k dash plus 1 हमारे पास आ चुका है 5.6. Now, what we are going to do, as you can see that the value after the decimal point is 6. That is more than 5. So, whenever the value after the decimal point is greater than 5, तो students हम upward round करते हैं इस data को. So, rather than taking it as 5, हम इसको लेंगे 6. क्यों? क्योंकि हमारा जो point के बाद, decimal point के बाद value है, that is more than 5. So that means we are going to locate the sixth observation from both of the sides of the arranged data. So students, counting on the values, number 1, number 2, number 3, number 4, number 5, number 6. So this is the value which is the lower limit. इसको हम लिख सकते हैं कि हमारा क्या है? ML. ML stands for the lower value of the confidence interval about the median. So students, ये हमने ML find किया, यानी lower limit of the confidence interval. इसी तरह से from the same data array, हम जो last observation है वहां से start करेंगे and we are going to locate the same sixth value. So 1, 2, 3, 4, 5 and 6. So we have obtained the value 45.2. That will be taken as MU. That means the upper value of our confidence interval. So students, this is the procedure through which we can determine the lower value as well as the upper value of the confidence interval. Now we are going to interpret this confidence interval. So we can state that we are 95% confident that our unknown value of the population median that we have determined through large sample approximation confidence interval is expected to lie between 19.1 and 45.2, where 19.1 was our ML and 45.2 was our MU. That means the upper value of the confidence interval about the median.